Welcome to Analyst Crossfire, an HPCC 2013 wrap-up show featuring expert voices from the high-performance computing community, giving their reactions to some of the top HPC trends as discussed at this year's conference. I'm Addison Snell with Intersect360 Research, and I'm your moderator for Analyst Crossfire. Joining me on the panel today are two vendors and two users who volunteered to share their opinions on any HPC topic I care to throw their way, giving us their personal views and not necessarily those of their organizations. Representing the vendor community, first we have Devin Jensen, who's the Vice President of Global Enterprise Computing Operations at Altair. Hello, Devin.
Morning.
Next we have Randy Schauer, who's a Senior Software Engineer within the HPC practice at Raytheon. Randy, thank you for joining us.
Thank you.
From the HPC user community, we have two well-recognized, highly esteemed luminaries. First, my longtime friend, Jim Kasdorf, from the West Branch office of the Pittsburgh Supercomputing Center. Never shy with his opinions, though we'll see how he does with a clock. Welcome, Jim.
Thank you.
And finally, from NCAR, the National Center for Atmospheric Research at the University of Colorado at Boulder, Henry Tufo. Henry, thanks for being here.
Thank you.
All right, panelists, thank you all for joining me for HPCC Analyst Crossfire. Clock's running. Let's get started. Our first topic today looks at application performance metrics. The most common metrics of performance, such as flops, number of cores, or LINPACK, are not evenly relevant across the industry, or at least that's my proposition here. The question is, do applications in certain areas suffer from having inappropriate metrics? How significant is this issue, and what specific steps would you take? Henry, I'll start with you down at the end.
Well, I mean, there are certainly application areas that don't fare well on the current architectures. I mean, bioinformatics is certainly one of them. They have a wide range of application encodes. They perform very poorly in terms of percentage of peak. However, they have tremendous amounts of data that are flowing through that they need to analyze quickly and get science out of. So, I mean, I think for those applications, really sort of time to solution, time to insight is really the most important metric for them.
Jim?
Yes, well, I agree with Henry that time to completion is the most important, if not the only metric. The metrics that you've listed here are sort of data points. They aren't what one of my distinguished colleagues would call actionable intelligence, and so they don't, in fact, apply to any application except unless you run LINPACK in production, which I don't do.
Well, there are some supercomputers, however, whose applications could correlate to LINPACK. I'm going to push back on your easy time-to-solution answer a little bit here, though, because it's hard to stack up a supercomputer in isolation and declare what its time-to-solution is. Henry, take another shot at that.
Well, I mean, most of these applications that we're talking about that have been left behind are perhaps not the best fit for the tightly coupled MPPs that we've built over the last 5 years from DOE and NSF. They're much more, many task, bag of tasks types of computing with more complicated workflows. It's really a different paradigm that they're looking at. They fall much lower from the peak of the HPC pyramid than we typically focus on. I mean, that's a very, very narrow area. And so I push back and I say, really, it's looking at the appropriate architectures and the appropriate metrics, in particular science metrics, for those disciplines that's really important in the development of those applications.
All right, Randy, I'm going to come down to the vendor side here. What do you think?
So my opinion is that the significance is really based on the mission of the organization, not necessarily individual applications. When you have a lot of organizations that they buy a machine, they need to run multiple types of applications in multiple domains, one thing like LINPACK isn't representative of everything, and we need to be able to focus on the results that they're going to get based on their job mix and the balance of the system to achieve that.
All right, Devin?
Users have made it very clear to us over the years that turnaround time is extremely important. Our focus at Altair when it comes to high-performance computing has been to make sure that job turnaround time is quick, and especially in environments where maybe they want to throw 4,000 jobs a second at the system, to be able to swallow that, queue it, follow the policies, and all that's required. But from a user perspective, the answer is yes, it's important. And time to solution and innovation and intelligence is the cap phrase for Altair.
All right, well, let me get specific here in order to try to underscore the root of the problem, right? It's very easy to come back and say, yeah, you've got to manage all of these balanced jobs across the system. That's how we should really measure it. But in actuality, we look at things like LINPACK and the top 500 list. Now, NCSA just notoriously decided not to submit top 500 scores for blue waters. Given our suite of answers here about what's actually important for a computer, do you think that decision is good or bad for them, and is it good or bad for the industry? I'll go the other way now, Devin.
I'm fine with that decision. I respect it. It is notable for who they are. I have known commercial entities who could have posted for 10 years and done extremely well, but it's not their focus. They're more about, and I'm pretty sure that's what the case is with NCSA. They're focused elsewhere.
Randy?
So I agree. I think it's good for them, good for the industry if they're going to take a stand against something, as long as they have reasons behind it. There are a number of government agencies who acquire supercomputers that don't do top 500 because their mission is, classified, or otherwise they're just not interested in that. And as long as they can accomplish what they need to accomplish, and they can continue advancing their mission, then I'm fine with whatever approach they want to take.
Jim.
Yes, I won't speculate on Bill's motivation for not publishing the top 500 numbers.
You will speculate about it, you're just not going to say it.
Oh, okay. I won't articulate my speculation.
Go ahead.
But I think it's a minor positive in that it raises the issue of the applicability of the top 500 list. I think it's an interesting list. It gives sort of an inventory of computers. Yes, there are people who are missing, the national security people, and some of our colleagues in industry who notably have said that if they wasted their time running LINPACK, they'd be fired because they're supposed to be finding oil.
Henry, last word on the topic's yours.
I think that anything that gets us away from LINPACK as the sole measurement is a positive. However, NCSA did not do that in their decision. They did not provide additional metrics that showed how well their system was. And also
That's a good point.
And also, it would have been a fine decision, right, to turn around and say, look, we were not going to do LINPACK, but these are the 3 other metrics that we use that are important to us, and we do exceedingly well on them. They did not do that. I also think that given their position as, and given the controversy about the whole system, I think that not making a statement in that particular space was a mistake on their part.
I think it's clear that LINPACK and top 500 are good in terms of spurring investment at the top of the supercomputing chain in the long run, but clearly there are application categories like sparse linear algebra, for one, that are just not well correlated, and there needs to be room for not only the usage of, but also the development of supercomputers along those lines that might not be top 500 darlings, but are nevertheless interesting for those application categories. Our next topic builds on this. The pursuit of Moore's law has given us increasing numbers of cores, whether in multi-core CPUs or many-core accelerators. Faced with these emerging architectures, what kind of investment does it take for an HPC user to achieve efficient performance at scale? Devin, I'm going to start with you this time.
Compiling has been a big focus. Altair has a lot of solvers. We've done a great job of posting the results that we get with making Radios and others take advantage of GPUs, for instance. Being the first to take advantage of Xeon Phi has been interesting. I know a gentleman at Altair who sacrificed the temperature of his office because he gets those early samples in and runs them right there in his desk. People around the world want 24-hour access to that machine, so he comes in, finds it 90 degrees and works that way all day long with his door open. So
compilers and early access, Randy.
So I think the real issue is the time investment that researchers are going to have to make to port their codes to these new architectures, and some of it's compiling, but some of it is they're taking time away from what they're really doing and supposed to be doing to adapt to these new architectures, which continually are changing. And there's going to be some pain as we move to exascale, but I think there's a lot of concern in our community as an integrator and in the user community as to how we're really going to achieve efficiency here.
Right.
Especially when we see, commercial packages, not just homegrown codes, taking a while to adapt to these technologies.
Well, I'll push on your point of continuous change a little bit. Sure, things have always gotten faster, but in this case, you're actually looking at a disconnect in how we're achieving that performance, which does have implications on the programming and efficiency side. I intentionally started with the vendor side here to get the supply side view before we get down to the users. Jim, what's it going to take to use these things efficiently?
A lot of hard work. Sadly, it's gotten harder and harder to get efficiencies at scale. That having been said, efficiency may not be the key metric here. If you're running at 10% of peak and that's still the fastest time to completion, you might be happy. If you really want efficiency at scale, hire John Levesque.
Right, 10% of 100 is better than 100% of 5 is the idea. Henry?
Well, I like to sort of divorce things in terms of the efficiency at scale. Really, that's a misnomer. You're really interested. Most of the problems start at the single thread or multiple thread counts or single node. And this gives you really an opportunity in this field to go back and sort of refocus both on the architectural side, on the application side. We've got this very nice window in the next 3 to 5 years to go back and sort of rethink things from scratch and figure out what the right metrics are for efficiency or for power, for application throughput. And you look at the problems that the application folks are going to have over the next 2 and 3 years as these architectures start becoming more predominant, and you feel sorry for them. You saw the vector change from the Crays to the MPPs that occurred in the late 90s. It was very painful change. This is going to be much more difficult than that particular change. You're looking at what we used to do in a whole supercomputer, basically on a node in terms of the amount of parallelism, and now you've got to scale that out across multiple nodes.
Very, very good point. And, we've noted before that these different supercomputer architectural trends have had the tendency to take more of the burden of scalability away from the system provider and onto the software provider in terms of how to exploit these concepts of parallelism, which brings up the exact point. Do you think these systems or these applications are efficient today? Or are we efficient today? Will we continue to be efficient? Henry?
Well, if you take a look at the applications that run through many systems in terms of their percentage of peak, they're certainly not very efficient, even at very low core counts. So, when they move to scale, things only get worse, right? You have latency issues, communication, bisectional bandwidth issues. So, I think we're not very efficient today. The question is do we want to live with that and say taking 10% of a large number of cores is the best we can do? And I don't know the answer to that question.
Right.
I hope it's not the best we can do, but it may very well be the answer.
A small number of cores is exactly what we're at. We did a survey that found that the median response for the average number of cores used by a typical HPC job across the industry was 36 cores. That's your typical scalability. Now, that's a 1.5-year-old survey now, but still, I don't think a whole lot has changed. Jim?
No, it's you're right, but averages are misleading. We're talking about sites, important sites like Oak Ridge. They do achieve large core counts for many of their applications. We had that at PSC when we had large machines as well.
All right, thank you, panelists. For the next question, I'm going to take advantage of the fact that for the first time, both of my vendor panelists are ostensibly hardware agnostic. This is fun. That is to say that, Devin, you work for Altair's middleware and application side. Randy, you're with an integrator, Raytheon, and you're on the software side at that. And the end users, you can buy from whomever you like. So I'm going to take one shot at this question. In your estimation, which vendors are showing the greatest leadership or innovation for HPC? Jim, your turn.
Leadership, I like Intel for their chip production, not necessarily their architecture. For innovation in architecture, I kind of like NVIDIA. But again, innovation has to lead to something good, and innovation and novelty for their own sake are not necessarily something that's going to help me.
Picking one on each side of the chip war, Henry.
Well, I mean, it's hard to argue with what Intel is trying to do. Whether they achieve that or not is unknown, but they certainly bought up the appropriate IP real estate and the people, and they have the fab. So, I mean, I think Intel deserves great credit for taking that on. I think NVIDIA also, in terms of being a feisty innovator and a very rapid innovator, I think they deserve a lot of credit. But I would go outside of the United States and start looking at what China is trying to do, basically trying to build their own HPC ecosystem from the ground up so they control it. I think they deserve a great amount of credit for doing so. It'll be interesting to see what comes out of that particular initiative by the Chinese government. I also think the Europeans deserve a lot of credit. They picked up a lot of slack after the U.S. has sort of leveled out in terms of their HPC investments. I don't know that the projects that they have underway will lead to these great breakthroughs that they hope, but certainly they're trying to do so, and I think they deserve a lot of credit for doing that.
Yeah, going outside the U.S. with your answer. I also found it interesting you both went to the chip side right away. There's certainly a lot going on there. I might look at both of those same companies too, but in terms of specifics, I'd look at Intel and what they're doing with network fabric integration as being extremely interesting on the chip side. And NVIDIA, I wouldn't rule out the real leadership that they took with CUDA, which brought real C-like development to accelerators for the first time. Accelerators aren't new, but being able to program them like that was really a new step. Down to the vendor side, who's leading in hardware and HPC, Devin?
I don't know a hardware company that doesn't innovate. My 8 years...
Very wishy-washy. Come on.
I'll keep going. At Intel, for 8 years, my boss's boss's boss was Andy Grove, and he often reminded us this is high-tech's the industry of the quick and the dead. The panel I was on yesterday, working down the list, SGI, power provisioning with collaboration with Altair, HP, CMU integration, Intel with, I already mentioned Xeon Phi. It's absolutely required. They can choose where to innovate, but they all do it, whether it's in delivery mechanisms and/or software stacks and/or unique hardware and infrastructure.
Randy?
So I think from a broad perspective, I'm really interested to see the innovations that Intel's coming out with, whether it's based on their fabric acquisitions, WAM cloud acquisitions, they've been buying up a lot. So I'm really curious to see how they're going to merge all this together and benefit the industry.
Intel doing pretty well here so far, 4 for 4.
So from, people have kind of left out actual vendors. If I look at, the box vendors, I'm looking at Cray going, they're coming out with new storage systems, their big data systems. They're really taking a leadership approach in how to conquer some of the problems we'll be seeing in HPC in the future.
That's the first time any of you even mentioned storage going around. Everyone went right to the processor side. I was kind of looking forward to hearing stuff about processing in storage or file systems, things of that nature in terms of the file system software again, but still in terms of the integration and storage. Any good innovation there? Yeah, there's your answer. Okay, how about this? Any areas that need greater investment where the hardware community you think should be doing more? Let's go to Henry.
I think that what is going on in Intel, which you mentioned, which is the interconnect and getting memory onto the board, stacked memory. I think that there are more projects like that should be undertaken by NVIDIA and others, and I think that would be a huge advantage for them.
Jim, where do you want to see more?
I agree and have nothing to add.
All right, then I'll cut you off.
Interconnects, certainly.
Okay.
I want to see more innovation in expanding the bandwidth pipeline to the accelerators so we can get data to and from them a lot quicker.
There you go. Well, Devin?
Addison, this was the burning question that I came to this conference hoping to get a minute with Dr. Stephen Wheat to get answered. My first thought with the Intel acquisitions, especially those big noteworthy ones that have already been mentioned, was that they wanted to own the ecosystem, but I can see that it's a power play, power performance. As he told me in a hallway conversation, which I know he's fine with me repeating because he agreed that I could ask the question in public on a panel like this if given the opportunity. and that is that it's to avoid those hops, right? Somebody threw the number at us, $100,000 to move, was it 30 petaflops of data twice, 6 digits to, so yeah, keep that data right next to the processing, avoid those hops, and what they're doing with the infrastructure and the fabric and all that, yeah.
I hope you enjoyed those in-depth insights you got to do in the long answer format. We're going to squeeze in a few more questions, speed it up here. We go to the speed round. Government travel restrictions had a significant impact on the SC12 conference and now in effect also on this conference, the National HPC Conference, which typically draws a very heavy government component. How long before this effect starts having a deleterious result on the industry at large, and what's the right level of government participation, Randy?
So the government is our main customer, so not having them at these conferences is very painful. We look forward to being able to interact with them and understand what their needs are, and it makes our job harder as an integrator when they're a customer. As far as their participation, I think from what's been done, let's say 5 years ago, it'll need to be scaled back, but it has to be more than what they're doing now.
Devin?
Well, you can bring the mountain to Muhammad. They still accept visits. It is sad that they can't do more and be here more.
Jim?
Yes, when they start threatening conferences of this size, that's when it's going to really hurt. Threatening the existence of them. However, talking about SC, I think that the weapons labs booths had sort of gotten out of hand. I don't know.
Agreed.
I don't know who they were selling to or what they were selling, but there was a lot of chest thumping.
Need to right-size that, Henry.
Right.
Get used to it.
Yeah, you don't think it's coming back at all, huh?
No, and I think from the industry's perspective, we better hope that the transition to the commercial side in industry occurs. We've been talking about this for 20 years, and we better hope to God it happens now.
I hope it comes back, though. HPC is a community-based industry, and I agree that some of the investments we saw at SC were too big and needed to be right-sized. But you got to be part of the discussion here. This is a community, and you need to be talking to each other. Now, it's not only in the U.S. that we see softness in government and academia, with private sector investments are outpacing public sector globally in HPC. Is the end of the public sector drought in sight, and where's it going to rain first, Jim?
Well, it's going to rain first in Tennessee, but
specifically,
it always rains there first. Some places don't have a drought. I think Utah and NSA is getting the money that they want, but I don't see the end of the drought.
Henry?
I think it's going to be a long drought from the government side.
U.S. or worldwide?
Certainly U.S., probably I think the Europeans will not be able to increase over the budgets they put out there. I think Southeast Asia is probably the only spot that you might see significant increases.
Vendor side looking bleak in government. Randy, what do you think?
So I think we've got several more years of this before we see any positive turnaround. Until they can really put a full budget together that looks forward and addresses, national issues as well as HPC issues, we're in for a long drought here.
Devin?
Historically, Altair does well in downturns. People want more for less. That's always true. So we'll do well. Internationally, it's I have seen some pickup.
There are pockets in different places. UK is actually doing all right to the extent that they're somewhat isolated from the Eurozone crisis. We're also seeing an interesting amount coming out of Russia, and I wonder if that'll start putting heat on somebody if that grows. For our final speed round question, I want to play Stoplight. As we discussed this week, big data and other enterprise computing areas could provide for the potential spread of HPC technologies into new application areas. For each of the following, I want you to give me your quick assessment of the business computing growth opportunity. As green, which is go, 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 yellow, proceed with caution, or red, you can forget about it. InfiniBand, how much can that expand, Devin?
Green.
Green. Randy?
Yellow.
Yellow.
You're asking HPC people about enterprise markets. I would say red for all of them.
You're skipping ahead. Red on InfiniBand? I just don't need to call on you again. You're going red, red, red all day?
I sat next to the guy who ran business computing for Westinghouse for a very long time by IBM.
Henry, InfiniBand going into business computing.
Green.
You're going green. Yeah, green, I can make an argument for yellow, but I see the need for increased bandwidth there. Green's probably the way I'm going with that one. How about Luster? Go on the file system side. Henry, you first.
Yellow.
Yellow for Luster, Jim. You're already on red.
Red.
Randy?
Yellow.
Yellow for Luster.
Yellow.
Yellow for Luster. We're going to need to do a lot with Luster to bring it into the enterprise. Parallel file systems not well adopted in commercial yet, let alone ones entrenched in open source. Final one is GPU computing. Jim?
Red.
Red. Okay. Randy?
Red.
Red for GPUs. Devin? Doesn't agree.
Green.
He's coming out green. GPU computing in enterprise. Henry?
I'm going to sit in the middle and go yellow. I think it's case
See
by
how much
case.
fun this is and how hard it is to predict this stuff? All right. Thank you, panelists. We're going to wrap up with our traditional Analyst Crossfire final question around the table, which I call one up, one down. You've experienced the full HPCC 2013 show now, and I want each of you to tell me what's one thing that surprised you in a positive way. You got a winner, but also one thing that perhaps you're disappointed in or you expect something better, Devin.
I learned a lot about big data, different perspectives, very pleased with that. Yeah, sad not to see more government participation.
Sad not to see more government participation. Is going to be a big one across the board. I agree with that. And big data, I like it. Good answer, Randy.
So my winner was the user stories we heard, and the challenges they overcame, and the challenges that still face them that we need to address. And obviously, my disappointment is also in the government participation.
You make a good point, though, on the end user side. In compensating a little bit for the lack of government, there's a little more industry outreach. We got to see presentation from banking, from pharmaceuticals, from manufacturing. Fantastic, great use cases right across the board. Jim?
Yes, I'll go with the use cases, and of course, England Go is always impressive.
I got to follow him every year. That's just not fair.
Tough job. On the downside, Terry Quinn wasn't here, and
no, little shout out there for Terry Quinn. I appreciate it. Henry, last word's yours.
I'm going to. There's been a lot of bright points, but I would say that Intel's positioning with respect to the memory subsystem, the interconnect, is probably the most important development from my perspective. It really allows you to do integration at the node level as well as integration across the system, and if they're successful, it will be a huge plus for the industry. The negative, I hate to say it, but I mean the hype around big data is, I think, not helpful to the community. Data has been around forever. Computers operate on data. It's really not anything new in some sense, but everybody's talking about it. I saw, an article in the paper about, searching through patient records to hopefully find some correlations about how cancer develops in this a patient set. I mean, these are all great things, but we've been doing this forever.
All right, I'm glad we have an extra minute here because this is the first time I've heard this viewpoint going with the big data hype as a negative here. You're just not buying into it. Big data's been around forever?
Well, data has been around forever, and our desire to learn from that data, to pull out new insight, has been around since the census, right? How IBM got started. I think that it's not helpful to the community. I think that really what needed to occur was more a rebalancing between our investments in compute and our investments in networking and storage, and that is occurring. It's going to occur naturally.
Devin, get in there.
Well, I think where Henry took us is the shortcoming, the roadblock is making sense of the data, and that's 6 years ago, 7. We bought a company that supposedly addressed all three, and it has all three of the business intelligence key areas that customers want. I know that the big players in that market were able to do 2 out of the 3, different 2s out of the 3s. And ever since, every utility company on the planet now runs Altair's business intelligence so that you can get that data down to the meter, when it was read, by who, and make sense of all that data to actually pull that quickly and make those, ahas and insights that change the world.
Data has been around forever, of course, and in HPC in particular, but what's undeniable is that the pace of the creation and accessibility of data from more sources of more types has increased to the point where organizations are having trouble dealing with it. And I think what we're talking about here is the applicability of HPC technologies to solve that in a broad range of user spaces that we maybe haven't traditionally addressed. But panelists, that concludes HPCC Analyst Crossfire, and with it, the 2013 HPCC Conference. I'd like to invite our audience to look for Analyst Crossfire again at the conclusion of ISC 2013 from Leipzig, Germany this June, where I'll be joined by new panels of experts on current sets of forward-looking HPC topics. I'd like to again thank my panelists, Devin Jensen, Randy Schauer, Jim Kasdorf, and Henry Tufo for joining me and sharing their insights, as well as John Miguel, John West, and the rest of the extended HPCC team for another successful National High-Performance Computing Conference. For Analyst Crossfire, I'm Addison Snell, Intersect360 Research. Thank you.